So when it comes to energy and work causing a change in energy, we can also look at how the energy is transferred and the conservation of energy. This is probably not a new idea to you. Let's say here's the ground. And we'll let the ground be at this position Y. And I'm using Y because our vertical direction in an XY coordinate system, this is X and this is Y. And since I'm going to look at an object that moves down, so maybe here's a box. Maybe that box is being held by a string, or maybe someone is holding the box, or maybe it's just sitting on a shelf. But there's a box up here. I'm going to call its initial position, where it is right now, Y initial. And so later, the box is going to be on the ground. And we'll make a little dotty dot here to represent the box position when it's on the ground here. And that will be our final position. Now, if our box is over here, and I think about what forces might be acting on my box, well, we have a gravitational force. And maybe there is a normal force acting on it because it's sitting on a shelf. So if we just isolate what's going on here with our gravitational force, so this gravitational force will be acting on the object as it moves from this initial position here to this final position there. So that gravitational force will do work. Remember, work is FD cosine theta, where the angle is between the force and the distance. And in this case, our force is straight down, and the displacement is also straight down. So our displacement will be straight down. And the angle between down and down is 0, so theta equals 0 degrees, and the cosine of 0 degrees is 1. This means that the work done by our gravitational force will be negative Fg, because it's pointing down, and then our distance or displacement will be the final position minus our initial position. So this distance here is the difference in those two places. Now, the gravitational force is equal to m times g, so this will be negative m times g times y final minus y initial. Now let's leave the negative sign out front and distribute the mg. So we'll have mgy final minus mgy initial. Now this looks very familiar to me because y is a position. This looks a lot like mgh. Our energy stored in a position is mgh. So this means that the work done by the gravitational force will equal negative Eg final minus Eg initial. So it will be the final gravitational energy minus the initial gravitational energy. Anytime you have a difference, that is a change. So we have a change in gravitational energy, but it's negative, and that is equal to the work done by the gravitational force. So this means that the work done by the gravitational force causes a negative change in gravitational energy. Let's look at that in more detail. So if here is the ground level and our box is up here, the force acting on our box is down. Our displacement is down as we go. Then this force is doing a positive work. But since energy is mgh, if this is a 0 position and this is some position greater than 0, then up here we're at a high energy, and down here we're at a low energy. So the energy is changing as the object moves from this initial higher position to this final lower position. And so there is a negative change in the energy of the object. Now, if that is the only force that is doing any work, then the work done by the gravitational force is the net work or total work done. And before we saw that the work done, the net work, is equal to a change in kinetic energy. In terms of energy, the work done by the gravitational force is negative change in gravitational energy, which would then be equal to the work by the gravitational force is then equal to our change in kinetic energy, and the work done by our gravitational force is equal to the negative change in gravitational energy. So I'm going to make a substitution of this change in EG for the work done by the gravitational force. So there it is. And then that will be equal to the change in kinetic energy. Now a change, remember, means final minus initial. So I could rewrite this equation as being negative mgh final minus mgh initial, and 1/2 mv final squared minus 1/2 mv initial squared. Remember, kinetic energy is 1/2 mv squared. So let's distribute that negative sign over here. So I'll have negative mgh final plus mgh initial is equal to 1/2 mv final squared minus 1/2 mv initial squared. Now notice that I have final conditions and I have initial conditions. Let's get all of our final conditions together. So if I do that, I'm going to leave the 1/2 mv final squared on the right side, and I'll add to it mgh final. On the left side, I will leave my mgh initial, and I will add to it 1/2 mv initial squared. So then now I see that I have initial kinetic energy and gravitational energy is equal to the final kinetic energy plus the final gravitational energy. So I could write this as EK initial plus EG initial is equal to EK final plus EG final. Kinetic energy and gravitational energy together are known as mechanical energy. So mechanical energy is defined as being the energy stored that you can see. So I like to think about it as I can see the object has energy. I can see that it's moving, or I can see that it has a position that's not 0. And so because I can see those things, those are mechanical energies. Chemical energy, electrical energy, thermal energy, those are all energies that you cannot see as readily. So this means I can write this equation here as being the sum of all of our mechanical energy initial should equal the sum of all of our final energy. When an initial quantity is equal to a final quantity, we get a conservation.